Hey everyone, today I'm going to be explaining question number 2.4 on our electric fields packet, and the question is as follows. A 0.06 kilogram electrically charged ball hangs at the end of a string oriented 53 degrees outwards from a charged vertical plate. The electric field produced by the plate at the position of the ball is 1.0 times 10 to the 5th newtons per coulombs and points away from the plate. Complete the table and determine the charge of the ball. So our objective here is to find the charge of this ball right here. So the first thing I would do is I would create a force diagram. So first thing we know is force string on ball, and let's just set up the force diagram. We know we're going to make the top positive, the bottom negative, the left negative, and the right positive. So we have force string on ball, and we know it's at a 53-degree angle. Then we have the force earth on ball. Then we have the force of the plate on the ball, and we know the plate is positively charged. And since the ball was repelled from the plate, we're gonna assume now that the ball is also gonna be positive because like charges repel. So the next thing that we want to do is you want to split the components of force string on ball. So we can draw like an arbitrary lines here, and if you calculate the angles, you would know that, well, this is given 53 degrees, and we know this is the right triangle, so it would be 90. So then 180 minus 90 minus 53 gives us 37 degrees, which is right here. And the first component we'll first solve for the y component. So I've already typed up stuff here, but we know the acceleration equals force over mass. So the force, sum of the forces, is the force string on ball times sine 37, again because we're getting the y value here, and then we're subtracting the force earth on ball because the force earth on ball and this force, the y component of the force string on ball have to be equal because, again, the ball isn't moving, the ball is staying in the same exact place. So we know the force is equal to 0. So what I'm going to do here, we can multiply the mass of the ball to the other side, and that would just take it off. And then after that, we can just add force of the earth on ball to the other side as well. So we know that the force earth on ball, remember, acceleration is 0, so we can write that, and we can just take that out actually. So we know that the force of the earth on ball is equal to the force string on ball times sine 37 degrees. And we know force earth on ball is the mass of the ball times gravity, so we can just replace that. So mass of the ball times gravity equals force string on ball times cosine 37. So now let's solve for the x component, because the x component is going to give us the force here. It should be equal again because they're not in motion. So the acceleration is equal to the sum of the forces over mass again. So the force of the plate on ball minus the force of the string on ball cosine 37 degrees, because now cosine is going to the x-axis of 37. So again, right here, and you divide that by the mass of the ball, and we get 0 meters a second because it's not accelerating. And again, we can do the same thing as before, multiply the mass of the ball to the other side, which will just cancel it out. And then we can just do the same thing, add force string on ball to both sides, which would take it off one side and put it here. And again, the acceleration is 0 meters a second, so we can just take this out. So now we know the force of the plate on the ball is equal to the force string on ball cosine 37 degrees right here. And the force plate on the ball is also equal to EQ. So, and Q is the charge, and we need to find the charge. So that's the whole purpose of the problem. And we know that that equals the force string on ball cosine 37 degrees because force plate on ball equals this. I can use a little bit of substitution and then just plug it in here. So you got that. So based off that, we know that tan 37 degrees is going to equal the, well, y over x, opposite over adjacent. And in this case, the opposite would be the y-axis, well, the y component of force string on ball, which we calculated right here. It's equal to for string on ball cosine 37 degrees, and then we know over here we calculated the same thing for the x component, which is force string on ball cosine 37 degrees. So what we can do is you want to find q, so we can multiply both sides by q, and I would take it off on one side, and then we can multiply it here. Then we have tan 37, q tan 37 equals mass of ball times gravity, and we'll divide it by e, and what we're going to do is we'll just divide both sides by tan 37 as well. So q equals mass of ball times gravity divided by e tan 37. So now all we need to do is we just need to plug in our values, because we've solved it qualitatively. Now let's just add the numbers in. So q equals mass of the ball, which is 0.06 kilograms, which we can see right here in the top, and you divide it by 9.8 meters a second squared, because that's acceleration of gravity, and then you divide it by E, which is 1.0 times 10 to the fifth newtons per coulomb, and then we divide it by tan 37 as well. So if you plug it in your calculator, and if you round it, it should come to approximately a positive 7.8 times 10 to the negative 6, or 10 microcoulombs. So 7.8 microcoulombs. And that is the answer to question 2.4. I hope that cleared up some misunderstandings, or if you didn't get it, but I hope it's clear now.